Okay, for the power work energy, one important formula is work done by the engine or force, external force, is equal to change in kinetic energy. Like when we apply force on object, it can be used to change the kinetic energy. It can be used to change the potential energy, like the height, kinetic energy, speed, potential energy, height. And then it can also be used to overcome the friction or air resistance, work done against friction or air resistance. Okay, so this is the energy balance. This will be very useful. Okay, you can copy if you want, if you have not seen before. Every time you can start the power questions with that. Okay, energy and power questions. One more formula on a side note, one formula was power is equal to force time velocity. So that will also be useful. Okay, so I've shared a paper with you before. Let's open that one first. November 24 P43. November 24 P43. So this first question is actually from the that work power energy. Okay, so read the question and let's start it. Athlete has a mass of mkg. The athlete runs from a horizontal road at a constant. So first of all, since it is a horizontal road, so there is no potential energy change, right? So delta PE will be equal to 0. Okay. Total work done by the athlete in increasing the speed is 1541. So that balance work done by the force or the person, work done external, you can call it by the force, is equal to change in potential energy, which is 0. So change in kinetic energy plus work done against the friction or air resistance together. So work done by the force is given here, that we are providing here 1541. Okay, so change in kinetic energy, so half m v square minus u square. Okay, final speed minus u square. Then you have a con resistance force. Work done is force times distance. So resistance force is 24 and the distance moved is 50. So this should give us the answer. Check please the working first of all, then we can find the answer. I'll bring my calculator. Meanwhile, please try that. Yes, do you find the mass value?
I'm finding. It is 171.
Try again, Tayyab. Same equation will give you different answer. Try again.
62.
62 is correct. So no questions. All good. Sab theek hai?
Yeah.
Okay. I don't know if there is another question in this paper. Let's have a look and then we can. Okay, there is a power question here. I can see a power here. चलें नंबर 3 करते हैं. Okay. Car mass 1600 kg travels a slope. So now there is a slope. Okay, and we have the angle theta because sine inverse is given. So we know the angle. Okay, consider it known. Then because it's given here, there is a constant resistance of magnitude 240 Newton acting. Okay, so the car is going up. Mass is 1600 kg. So you can say 1600 g weight is equal to mg Newton. Okay, the resistance force, we can put a resistance force of 240 Newton. Car travels at a constant speed. Find the power. Okay. So when it is first of all, Tayyab, you give me idea. How should we start it?
And first, we will find the power of the resistive motion, which is 240 multiplied by 32.
No. Power formula is driving force time velocity. Power formula. This F is basically the driving force. We don't know the driving force. Okay. So when we know the driving force, we will find the power. So what we need to do, since it's constant speed, is there any acceleration?
No,
No acceleration. So that means upward forces are equal to downward forces. Up the slope equal to down the slope. Okay. So up the slope we have the driving force which we don't know, dF, driving force. But down the slope we have the resistance force 240, and then we have the weight component, right? Weight is also acting downward. So we need to break the weight into two components, 1600 cos theta and 1600 sine theta. Okay, 1600 g cos theta and that one is 1600 g sine theta. Okay, so we need that 1600 g uh, and then sine theta. Okay, got it. So okay, please wait here, I need to confirm something. G, I'm checking the marking scheme, little different thing here. An angle of this sine of sine inverse of 0.08 is equal to theta. So that means sine theta is equal to 0.08. Correct? We can say that the sine theta is 0.08, right?
Yeah.
So we will replace sine theta as 0.08 and find driving force. What is the driving force? Let's find it. G will be used as 10. G value in Cambridge papers is 10. So what is the driving force, Tayyab?
1523.
Okay, 1520. And now you can find the power. Power is equal to FV. Yeah, 1520 times 32.
It
For
will be
its
48,736.
yes, 48,640 watts. Answer. Next, find the acceleration of the car. So now the driving force will be changed because the speed has changed, right? Okay, so now comes some trick here, some trick here. We find the acceleration when its speed is this and the car is working at 95% of the power. Okay, we can find the, you tell first, any idea?
So first we have to find the 95% of the power.
Okay, great. So power is equal to 0.95 times 48640. 46208 watt. Then we find the uh, minute speed. It is so driving force, power divided by speed. So driving force is 1925.3 Newton. Clear so far, right?
Yeah.
Then we can find the resultant force, right? So F resultant driving force is this upwards. Weight doesn't change, so that is still the same. What was it? 1600 times 10 times 0.08. What was it?
It was 1,600 kg.
No, I'm getting 1280. Weight component downwards. 1600 times 10 times 0.08. 12
1,280.
1280. And then there is also the resultant, the resistance 240. That also we subtract because it's downwards. So resultant force upwards is 405.3 Newton, right? Got it?
Yes.
So we have resultant force and you can find now the acceleration. The mass of the car is 1600 kg.
It will be 0.25.
Okay, three decimal place, three significant figures, 253.
0.253.
Okay, that's right according to the marking scheme also. Okay, no questions, all good, right?
Yeah.
Okay, then we can try another from the next paper, same topic. So this is also power. Work done and power is the same thing, right? Similar, same topic. So let's try this. I'll bring my notepad and you also try on the paper first. I'm doing it. I need some time to figure it out. You can also try first, okay?
Sir, okay.
Keep trying meanwhile. Mhm. G. Okay, Tayyab, I have solved
Yeah,
it.
I'm getting it.
Yes, tell me, please, your answer.
I'm getting 4.6.
4 point.
6.
Okay, that's incorrect. Can you tell me the working, please, from the start, how you did? Or send a photo
I
of your
use the for
working.
uh, I use the formula work done is equal to the the resistive work done and plus the kinetic energy.
Work done is equal to potential energy change plus kinetic energy change plus work done against the friction. Okay. Now, there is actually signs are different here. First of all, what is work done against work done by the force? The left side. What is the left side value?
It will be 20 sine 30 multiplied by 2.
20 sine 30. No, work done by the force. Is there any external force or engine force acting on the particle?
50 joule.
No, no. That is the resistance
Mm,
force. This is 50. Okay. Is there any force acting on the particle? Driving force. Is there someone pushing the particle, the block of mass? No, right?
no.
There was, yeah. So there is like no engine attached, no rope attached. So there is no driving force. So there is no driving force. It's zero. First of all, there is no external force. There is just a push. सिर्फ उसको टॉप से पुश किया था. ठीक है. But then it is on its own. ठीक है ना? It's on its own. So work done by the driving force df, work done df is zero. Okay. Because in the previous question you remember that there was actually engine, power of the engine. But here there is no engine. Okay. Then the potential energy. So the object is moving down. So there is a loss in potential energy. Agree?
Yes.
Agree? There is a loss. So that means we will give negative sign to potential energy. Okay. You can note down this point. If it is coming down, particle is coming down, potential energy change is negative. If particle is going up, it's gaining potential energy, so it will be positive. Okay. So negative mgh, G, and H. Now I need H also. What is the height when it moves 2 meter down the slope? Did you find it?
No.
No. Okay. What you need to do? That's the slope. Suppose that that's theta 30 degree. Suppose this is 2 meter. The block comes from there to there, right? 2 meter down. Fine.
Yeah.
Okay. This is hypotenuse. It's a right angle triangle. So this is height. So can you find height using trigonometric ratios?
2 sine 30.
Yes, which
It
is
will be
1.
1.
1. So we found the height also. Height is 1. Keep kinetic energy like that, delta KE. Just keep like that for a while. And work done is positive. Okay, work done against resistance. This is actually done. Okay, because potential energy was lost. It was converted. So it's negative. Work done is done against the friction. So it is positive. Positive 50. Okay, so signs are important. It will always be positive. Work done against friction will always be positive. The KE and PE, they can change signs. Okay. So now we will find KE. Okay. It's 150. And then you can do 150 is equal to half m v square minus u square. U is 5 square. 5 square. Okay. You can find v from here. Please try.
It will be 6.32.
That's correct. Got it? All clear?
Yeah,
Okay. You can take notes. Any notes you want to take?
okay.
So potential energy negative when an object is going down, okay, like down the slope, and will be positive if it is going up the slope because gain is positive, loss is negative. Okay. Kinetic energy we found out that it is positive and it should be positive because something is coming down, falling. So its speed will increase. So actually, yeah.
Okay, sir, done.
Okay, that was the first question. Okay, this is also power. Okay, so two questions powers. Chale, let's do that. Right, a cyclist is riding along a horizontal road. The total mass of the cyclist on this bicycle is 90 kg. Let's draw diagram. When I draw diagram, I can visualize things, easily. That's a cycle. Its mass is 90 g Newton. Weight is 90 g Newton. The power exerted by the power is equal to 250 watt. At the instant when the cycling speed is 5, his acceleration is this. So when the speed is 5, let's find the driving force. F driving force. F driving force is power divided by the speed 5. Okay, 50. Driving force is 50, right? Then acceleration. Find the value of the constant resistance. So forward force, now we know FD is equal to 50. And we don't know the backward force, right? That is now the resistance is the unknown force. F, you can say resistance, right?
Yeah,
So can you do from here question? Can you try first if you
yeah,
have idea?
okay. Let it be 41.
41, what is 41? The resistance force?
Yeah,
Okay, great. Perfect. All right. The cyclist comes to the bottom of a hill inclined at 2 degrees. So now it is an inclined plane, 2 degree. Given that the power and resistance are unchanged, find the steady speed with which the cyclist could maintain when riding up the hill. Steady speed. So acceleration is zero, right? Okay, think about it. Acceleration is zero, power is unchanged. That means driving force is also unchanged. 50, and the resistance is also unchanged, 41 Newton. So, and weight, you have now weight of the cyclist. The component will be acting down. It's 90 kg, 90 g. So you have the components. Okay. Okay. Try please. I will also try on the paper first. Okay, hold on. I don't think driving force will remain same. No, because it's they say power is remain same, but driving force and velocity can change. So I will erase this part. I don't think so. Okay.
I think I have done this question in school one.
Yes, yes. Do you remember the solution?
Yeah,
Okay. You can still do again. It's fine. But next time tell me immediately, then I will change the question. Okay.
yeah, okay.
Because I'm going to open latest paper also in the classes. It's good to do the latest paper, and also students like to do the latest papers. Okay, find it please.
The velocity will be 3.45.
Okay, you have done it right.
Yeah,
Yes, 3.45. Okay, well done. Let's check. I don't think there will be another question like that. So now what should we do? Any particular topic, or shall we continue the past paper as in sequence?
I have a test of pure mathematics and mechanics both on Wednesday, so that's why I was practicing for this topic.
So today you want to continue with mechanics?
Yeah,
Okay. So let's do question two. Start with two now.
and not for this topic.
Can you repeat what you said?
I, I have test for that one topic, power and work energy one, not for these one.
So you want to stick with that topic, right?
Yeah,
Okay, let's do more then. 24. March 24. Let me save it 1 second. Desktop Tayyab. Hmm. Okay, you can start this. I'll be back from toilet. Please wait.